Hello everybody. Okay, so we will talk about the final exam today. I will leave the PowerPoint slide to be like in this um, editor's view so that I can make changes uh, if needed. Okay, so I'm not going to play it. All right. The final exam will be on next Tuesday. So I'm preparing two parts for the final exam. The first part will be some questions, like the quiz questions that you have already taken on Canvas. So these questions are uh, kind of a test for knowledge or concepts, uh, basically about all chapters uh, covered by this course, covered in this course, okay? So the questions will be multiple selection, simple answers, and I will prepare 20-ish questions in total, okay? And for the, so I will go through this first, and then I'm happy to take questions, okay? So the second part will be a Jupyter Notebook based uh, programming test. So I think there will be 7 to 8 cells. Like each cell is a more independent question. Okay, and all the tasks will be very similar to the code filling tasks in all the assignments. I think the difference from the assignments is that in the final exam, I'm not going to have questions based on large scale projects. Like I'm not going to include realistic data, like the the digital picture data or the sign language data. That's not what I'm going to do. So all the data, if needed in the programming task, will be some toy data sets. It could be some arbitrarily created random numbers or small matrix, small vectors. Just the purpose of those toy data are just for the task, not for a complete realistic project. So yeah, there will be 7 to 8 questions that requires you to fill out the code. And for the tests, I think I'm particularly going to focus on NumPy with vector, matrix, and tensor multiplication as the primary focus. Okay, there will be one more slide about this. And next, for the schedule, yeah. So because now we have a Canvas-based questions, so I'm thinking about we have this time slot from 10:30 to 12:30 reserved at the university level by the university. So the part one, the Canvas-based questions will be released at 10:30, okay? And the deadline will be 12:30. So you need to submit everything before 12:30. All the 20-ish questions, you need to fill in the answers and submit before 12:30. And you have 2 hours to do the Canvas-based questions. And for the programming tasks, so I hope to give you more time and the flexibility in completing the programming task. So I'm thinking about release it at 9 a.m. And but I don't also I don't hope that will influence your Canvas-based task, right? So I hope that during 10:30 to 12:30, you should all still focus on the Canvas-based task. But for the part 2, you can start start working on it from 9, or if you don't feel comfortable doing that early, you can also start working on that after the Canvas test ended. Okay. Oops. And the due time will be Tuesday midnight. Okay. So you just need to remember to submit a Jupyter notebook before Tuesday midnight. All right. So next, for the grading part, and as we have, you can see the syllabus on our Canvas page. That's the final exam takes 20% of the final score. So now since we have 2 parts, so each part will take 10% as the weight within the final score. Okay. So basically, I think for the Jupyter, for part 2, for the Jupyter based, I will provide the expected outputs for each cell so that you will know instantly like whether you did it correctly or not while you are doing the task. And for the Canvas based multi-selection and the short answers, I will also make the provide the instant feedback. Okay, so you can basically know your performance right after you have completed. Okay, so I have one more slide for the programming questions. So I think these parts are what you need to have a better review about. So so first of all, the usage of NumPy will be the main focus for this test. The built-in functions from NumPy, like the summation functions, and also with, I like to emphasize it here with the axis parameter. Put it in parentheses. Axis parameters will be importance in determining the shape of summation operation. Okay, so these kind of techniques about NumPy will be tested, and the vectorization is something that's is a common practice in NumPy. Okay, like you sum up all the like take the mean square error as an example. So you basically need something like y hat y is power 2, right? And these equations are valid even if those y hat and y being subtracted or being added are vectors. So there will be basic questions like similar to these types of mathematical expressions. And also for matrix or tensors, I will have questions tests the computation or matrix multiplication, so which can basically achieved by the dot products in combination with the transpose operators in NumPy. Okay, so those basic NumPy operators will be the basis for some questions regarding neural network, like the forward pass and the backward pass computation. And there will be a lot of matrix multiplication involved. So the neural network based, the second bullet, the neural network based or computation graph related questions will be kind of built on top of those NumPy NumPy basic questions, and but in a more contextualized style. Like we are given, for example, given the equation of back propagation, right? And given several concrete vectors or weight matrices, how do you implement the back propagation, right? With several lines of code. So yeah, that is all the slides I have today. And if you have questions, I'd like to answer your questions now. Let me enable the, right, I think you can, yeah, unmute yourself and speak.
Ask a question?
Right.
Yes. So, recently, of course, we learned about the Gaussian models, et cetera. And I personally found those a little complicated. So it seems like the final is more basic and general skills that we've been using all semester. Is that true? Or should I really try to understand the math behind the Gaussian models? I want to understand it, but it was hard. So I'm just wondering.
Yeah, I wouldn't worry too much about Gaussian. I will place 1 or 2 questions asking about the concepts of Gaussians,
Okay.
but there will not be concrete, like very specific numbers tested to the, for example, to the PDF functions. No, there will be no numbers related questions, numeric computations required for Gaussian. And yeah,
So
but
then could I?
there will be questions testing the concepts, like why we can use Gaussians to do clustering, for example, and what does it mean for a for example, in a mixture of Gaussian case, what does it mean that each data point can be assigned to several different distributions, right? So these are concepts. The concepts will be tested, but not the specific computation.
Okay, so could I check my understanding with one of the concepts of the Gaussian models? So when I was watching the lectures and stuff, so I guess is the overall underlying idea that, as you mentioned, in the natural world or in the world, a lot of things have a normal distribution, and you take the log of them or whatever. And this is in biology and finance and everything. And so is that why we use the Gaussian models? Because we say, well, we know that things in the world have a normal distribution, so we're going to say that any clusters and patterns that exist would be normally distributed, so we can find those, or something like that?
Yes, yes. So the observation that Gaussian is very commonly observed in nature, in our environments, it is the basis. So that's why we can use Gaussians to model those data. And another why is that Gaussians can be better interpreted. We can give a mean value and give it a standard deviation to describe a cluster. So we can explain the shape of a group of data, and by assuming that they are generated by a distribution, generated by a random process, by drawing from a distribution randomly, right? So that provides some I would say more convenient and lucid explanations to the parameters. Our parameters, the mu's, the sigmas, have more explicit meanings in Gaussian models.
Okay, that makes sense. Thank you.
Yeah.
I have a question. I just wanted to confirm something that I read on the syllabus. We are allowed to use the slides during the final?
Yes, you are. You are.
Okay, perfect. Thank you.
Just gonna ask another question then.
Mhm.
So I know we've talked about tensors, in this class and used them a lot, but sometimes in my mind, I'm still like, what's the difference between a tensor and just like a matrix with lots of dimensions? Or is that a tensor?
Yeah. So a tensor is a data structure that is similar to a matrix, but it is of higher dimensions. A matrix is a two-dimensional data structure, but it's a slice, but if you put two or more slices together, it's a cube, right? And a tensor can be of even higher dimension, like you put two cubes together, right? Then you have an index for each cube, right? So that index belongs to the fourth dimension, right? Because a cube is already three-dimensional. So you have one more additional dimension to index the cubes. And like even higher dimensions. But the questions that I am preparing for tensors or higher dimensional matrices, I don't think is extremely difficult questions that requires a lot of tricks in understanding the dimensions, but it's at the same level as you manipulate matrices and vectors. So it's more like a test of NumPy grammars, NumPy syntaxes, like how you use the uh, indices to access elements in a matrix.
Okay, thank you. Which is something that I sometimes get a little mixed up on. So I guess, so just because sometimes my friends ask me, because they hear these words and I'm like, technically I'm supposed to know this is now. And so I guess if you had a matrix that was like, yeah, that was a cube, technically that would be a tensor because now it's more than two dimensions. But really, I guess the point of tensors is you have like multiple compartments kind of all together that you can then access and deal with.
Yeah, I think that concept of multiple components is correct.
Okay. Okay, that makes sense. So it's simpler than I thought. That's good. Okay, thank you.
Mhm. Yeah, by the way, the slides that I show here, I haven't uploaded to Canvas yet, but I will provide it later, okay? And I will upload the video together with the slides.
So, Professor, I have a question that's related to the PyTorch.
Yes.
So in this class that you show us that at the very beginning that we do not really use the PyTorch or other kind of like the modules help us to do, we only do the specific, the basic structure and also the process of all the machine learning algorithm. But in the real world that when kind of like in the future, when we try to build up some models. So the PyTorch or this type of the module, they can not just help us easier to build the model, it can also accelerate the speed, right? So because we are not very sure about, so because before when I write a research paper, I prefer to use more things like the basic structure things. But right now I realize there are so many packages. So all these packages, they have already well designed. Is that correct? So in the future, if we want to build up some kind of like the fast build models to apply some real cases.
Yeah. I think it's a good point that of course when you want to implement your own model or either you want to replicate someone else's paper, then the quickest way, the best practice is to uh, look for online repos, existing code that already implemented. And nowadays, I guess the most recent papers, if it's I was a good paper that's worth reading, we usually provide repos. So one of our goals, I think the primary goal for our course, for this course, is to um, have a thorough review and have a thorough uh, lessons, tutorials about the underlying mechanisms uh, to the basic mathematics of the machine learning models, rather than hiding these details apart. Okay, so um, so for the final, at least, I'm not going to test PyTorch, for example, uh, test the usage of NNDOM modules and how you uh, set up a linear layer, for example. Well, those are really the basic techniques if you want to use PyTorch correctly, okay? But, well, I'm not going to like 100% sure for now, but because I am still developing my questions. Say, for example, if I'm going to test, have a question about PyTorch, I'm not going to let you guess the grammars of PyTorch because all those things will be available online, and I will point you to the correct documents, for example, the official documents from PyTorch that you can read, that you can check the usage of PyTorch APIs, PyTorch functions. And but I'm going to um, contextualize the questions within mathematic bases. Like, for example, if I define a PyTorch layer, define a layer within a PyTorch module and then DOM module, and if I define the shape of it, I'm going to ask, what does that shape mean? Okay, so what is a linear module that has 100 by 50? What does it mean? What does that mean? The input is 100 and the hidden layer is 550, and so on. So if I want to connect this 100 by 50 layer to a next layer, what should be the size of the next layer? Yeah. So questions like that. Sorry, I need to mute myself for a second. All right. So I hope that answers your question. Okay, any other questions? Concerns about finals? All right.
Council, I'll just make a comment.
Mhm.
I just want to thank you for being such a good professor this semester. I know it's been really hard with everything being online, but I feel like you explained the concepts really well, and everything was very clear. And I really appreciated your use of Canvas and making things kind of modular or organized, which really helped when I got behind and then had to go back and rewatch all the videos. And I've told some of my friends that this is a good machine learning course, I thought. So I just want to say thank you for putting in all the effort.
Thank you so much. Thank you for your kind words. Well, to be honest, there's still pity about what's been missing due to the limits of online lectures. I am I was not used to this way of teaching uh, at the beginning, or I would say I'd prefer to see everybody in a classroom, and some of those concepts, the mathematics will be better revealed on a whiteboard and with some hands-on practices. And I'm going to improve that because we have one more semester online at least. But yeah, I really want to thank you for attending the course and for thank you for all your questions about assignments You actually helped improve the way I teach, improve the structure of the course, improved how all the assignments and slides are presented. So yeah, thank you all, and it's really nice to spend a semester, an unusual semester, with all you guys. Yeah, I hope it's not. It's gonna be life's gonna be easier for everybody in the coming new year.
Oh, there is another question. Do we need to attend the Zoom when we have the final, or
No,
just?
you don't need. You don't need to.
Okay.
Yeah, just follow the deadlines.
Okay. Thank you.
Um, Alrighty. Okay, so looks like we have no more questions, and I'm going to upload the video anyway, and I'm happy to answer your emails at any point before the tests. Okay, and yeah, I can also um, let me see. So during the part 1 of final, I can open my Zoom and have a live question answering session. If you have questions about the questions, you can jump in and discuss it with me. Yeah. All right. So I'm gonna end the Zoom meeting now, and